So my name is Hamish Weatherly, and I'm a hydrologist with BGC Engineering, and a hydrologist studies the surface water. And I'm presenting this evening with my colleague here, Trevor Crozier, who's a hydrogeologist. So Trevor studies the groundwater, and we'll be tag teaming this presentation, so we'll be switching off as we get to the various slides. One additional member of the team who isn't with us here this evening is Jessica Mackey. She's with Knight Piésold, and she studies water quality. So it's a very iterative process that we deal with in terms of the interactions between surface and groundwater and then the water quality. So just to provide some context about what we're studying today here. So what we want to do at first is we want to establish the baseline conditions at site. So at the project site, what are the stream flows? How do those stream flows vary from day to day, from season to season, from year to year? The same with groundwater levels. What are the groundwater levels like around the project site? How are they varying seasonally? How are they varying on an annual scale? And we also want to know these same parameters. What do they look like upstream of the project site, and what do they look like downstream of the project site? So those are our baseline conditions. And then what we do is we establish a model, and then what we want to do is, what is the impact of this mine site going to be on the groundwater, on the surface water, and on the water quality? So that's the overall picture that we're looking at here. And that's sort of encapsulated in this slide over here, which is showing the EA methodology. I apologize that we have the two screens up here, so it might not always be visible for people. But we start off in the EA methodology by establishing our baseline conditions. And so what we have to do is we have to collect data. So what data do we have to collect? We have to collect data on the climate. So how much rainfall is occurring, how much snowfall, how much snow melts, how does temperature vary throughout the year, wind speed comes into some of the calculations also, and the relative humidity. And then we also want the stream flow, so the surface waters that are in the streams. Again, we want to measure that both at the mine site, upstream, downstream, and groundwater. We want to collect the levels, as I said, not only at the project site, but upstream and downstream. And when we collect these baseline data, we're actually following very strict provincial guidelines for each of these parameters. So there's guidelines for collecting surface and groundwater quality. There's guidelines for setting up a station to measure stream flow. And there's guidelines for setting up a groundwater well and sampling from that. And then we move to our next box, which is the modeling. So we want to model the existing conditions. We want to model the stream flow. We want to model the groundwater. And what we do is we establish what is called a water balance model. So this is what's coming into the site, what's leaving the site. And then what we do is we establish water quality source terms to assign to these various streams of water. And then we make water quality and water quantity predictions. So that's where we get into our effects assessment. So what changes in water quantity and what changes in water quality are we going to get, or what we think we're going to get because of the mine? And then it can be a bit of an iterative process, because what we might find is, just as I'm going to throw out an example here, we might find that there's going to be a change in the stream flow of 10%. That's just a number I'm throwing out. And then we would give that, say, to a fisheries biologist and say, is that significant? And the fisheries biologist would do his analysis, her analysis, and determine if that's significant or not. And if there is a significant impact, it's an iterative process. We go, well, what can we do to minimize that impact? And it's kind of a loop that we then follow. So if we step back and just look simply at what the hydrologic system is, this is a very simplified model of what we're looking at. So in this case here, we have rainfall falling onto the terrain. Some of it percolates down into the soils and reaches the groundwater table. And then the groundwater table throughout the year is feeding our stream flow. But also a portion of the rainfall goes much more quickly towards the stream, and it runs off as surface runoff. And then we also get, especially in this region of BC, we get a lot of that rainfall and snowmelt is lost to evapotranspiration. So these are the trees using that water to grow, and the trees also can evaporate that water also. And then we also have large water bodies such as Jacko Lake or Kamloops Lake, where we get evaporation directly from the lake water surface. So if we look at where we're doing some of the monitoring, this is a topographic map of the study area. So we're right down here in Kamloops. And these are the two watersheds that we're principally concerned of right now. So the one in purple right here, the one on the right is the Peterson Creek watershed. I don't know if I can show it right over there. So right in here, this is the Peterson Creek watershed. And then the one right next to it in red is the Cherry Creek watershed. So those are the two main watersheds that the project is within at this moment. And then we also have this third type of watershed. Apologize, this pointer's not working very well, and that's in brown right here. And these are closed watersheds, so these are essentially like basins. There's no surface water outlet. There's no surface water flows out of these basins. An example is Inks Lake, if anyone's ever been up at Inks Lake. There's actually no surface flow out of there. Doesn't mean there's not water coming out of Inks Lake. There probably is as groundwater, but you don't actually see a stream leaving that particular lake. Trevor's just going to talk a bit about the groundwater.
Sure, so this is a similar picture showing a slightly larger area. Kamloops is down in this range here. Kamloops Lake, red oval is the project area. This black outline is the approximate regional study area, so that's where we look at all of the available data that's been published in the area, or what the BC government might have in its Water Resources Atlas, or MOE might have other reports in the area. In purple here are the mapped bedrock aquifers in the area. There's a number of them. They're all just shown in one color here. In the light blue, cyan hatching, you can see here. Here, there's the Peterson Creek aquifer. There's Davidson there. Those are surficial aquifers. There's a Cherry Creek aquifer over in here. In red, these red wells here are groundwater wells. These are registered wells that are used for irrigation or for unregistered use. There's abandoned wells. There's commercial wells in yellow. There's an observation well run by the ministry just down in here. There's some water supply wells. All of this data is available. It's registered for the wells in the area. It's available to us through the Ministry of Environment. We use that data. In green, one of the other things that we've considered here is the water supply limits from the city of Kamloops. So what we're interested there is who might be using well water for potable uses or for crop watering, who's getting their water from the city of Kamloops. There's the city of Kamloops limits. And we've also, in this area, just to give you an idea of the size that we're considering, this blue line is the lower area of Cherry Creek watershed. It's considered in the model as well, or will be. And there's the Peterson Creek watershed in orange there. So there's a fair amount of data available to us just by looking at existing sources. Turn it back over to Hamish.
So now we're just going to discuss a bit about the modeling approaches that both of us undertake for our studies. So there's a surface water balance model, site-wide, and there's also a groundwater model that Trevor develops in his studies. And so the water balance model that I've been developing for the project site, it's been set up in Excel. So Excel, if most of you are probably aware, it's just a Microsoft product. And it's, a lot of people know how to use it. It's not overly complex, but the model does a good job of simulating stream flows, both during the summer and the winter. And how it's set up is I'm not looking at stream flows on an hourly or a daily basis. I'm actually looking at them on a monthly basis. And the most important part of the whole modeling process is calibrating the model to observe existing conditions. So that's what I do initially. I have observed stream flow data, and I set up my model, and I calibrate so that I'm providing a good representation of both the seasonal fluctuations in stream flow, but also annually, year to year. And what I do as inputs to the model, I have precipitation as an input. Temperature is an important input because I have to know when snowmelt is occurring and whether the precipitation is falling as rain or snow. And also evaporation is an important input because, as I said, in this environment, you lose a lot of the rainfall, a lot of the snowmelt to evapotranspiration. And it goes into the model, and the model is separated up into various watersheds areas. And each watershed area has various different land types. And each land type, so it might be undisturbed ground, it might be the mining environment, it might be the open pit, it might be the tailings facility, it might be waste rock. And each of these different land types has a different runoff characteristic and a different water quality. So that's all captured in this larger model. And what we get as an output is stream flow and water quality when we merge it with the water quality model. And the water balance model, it just doesn't look at existing conditions. So I set it up initially for existing, and then I superimpose the mine site. So then I evaluate how does the mine affect the stream flow. And then we're also looking at the closure and post-closure periods. So the closure period is when the mine has stopped operation and they're reclaiming the various landforms. So they're putting a cover on the waste rock or a cover on the tailings facility. And once those facilities are covered and vegetated up, then we enter the post-closure phase. Because obviously you can imagine if something's vegetated versus non-vegetated, it's going to have a different runoff characteristic. Just on the right part of this diagram here, this is sort of the typical runoff that we see in the Cherry Creek and the Peterson Creek watersheds. So very little flow during the winter period and into the late summer and fall. And we get most of the runoff associated with the spring melt. So April, May, June is when the highest stream flows are in this area of BC. Oh, let me just go back here quickly. And so the principal objectives of this water balance model are to assess the impacts of the mine at various stages of development on the stream flow quantity, not only upstream of the mine site, but at the mine site and also downstream at various locations. And we also merge the model results with water quality data to estimate future water chemistry, both at the proposed mine facilities and down gradient. Now we'll move on to the groundwater modeling component.
So the groundwater model will most likely be developed using a code called ModFlow that was developed by the US Geological Survey. It's a robust code that's used to develop groundwater flow models in 3 dimensions. It's been benchmarked to a number of case studies, and it's widely used and accepted in this type of a study. The model will be developed according to or consistent with the guidelines that are available for us in the province of British Columbia. The Ministry of Environment has put those out just recently. And similar to the surface water system, we've got to be aware of how groundwater fluctuates in this area. So we're going to look at summer and winter stress periods. So if you think it's winter time, there's snow on the ground, it's very cold, you're not getting a lot of snow melt recharging that groundwater system. So that's what I mean by a winter stress period. We wouldn't be adding groundwater into our model. During the summer, you've got high evaporative rates. You also have summer storms. You've got some snow melt. So you're getting recharge, but you're also getting water evaporating from your system. So that's winter and summer stress periods. We'll look at surficial and bedrock aquifers. All of those will be implemented and assigned characteristics that are available to us based on some of the classification studies that have been done in the province for those aquifers. And we'll calibrate to observe groundwater elevations and to stream flow measurements. We'll also apply precipitation and evaporation rates that are consistent with those inputs that are being used in the surface water model. As Hamish has done or will do, we'll be looking at existing conditions to calibrate. So we'll calibrate to measured groundwater levels in the area. That's some of the wells that we saw on the larger map, as well as to a site monitoring network that will be developed as part of the study. Then we'll simulate the mine infrastructure in the model. So we'll put on the waste rock facilities, we'll put in the tailings storage facility, we'll excavate an open pit through operations, and we'll evaluate how groundwater flow patterns might change during the operational period of the mine. And then we'll look at closure, how the project is proposed to be closed, what's going to happen at the end. Those conditions will be simulated, and we'll look at what those changes might do to groundwater flow. And on into post-closure, so after the mine's been shut down, what happens. The principal objectives of the groundwater flow modeling will be to assess the impacts of the mine on the groundwater flow patterns and groundwater quantity. So how much water is discharging to creeks, how much water is available in the aquifers. And to identify potential seepage migration pathways from tailing storage facilities or waste rock piles. So this is an area where you might get into some kind of an iterative scenario where you might look at, okay, well, we're predicting seepage from this facility. What can we do about it? If we put in a well to cut it off, or we put in a grout curtain to cut it off, what does that do to recharge to the stream? So that would be a scenario where we might go back and look at the different effects on surface flow or groundwater flow. As part of the study, there are some specific objectives to the assessment, and this will include a look at the potential impacts to Jackal Lake. It'll include a look at potential impacts to the Aberdeen subdivision, and we'll also look at potential effects to the Peterson Creek and Davidson aquifers. So we've talked a little bit about surface water quantity, groundwater quantity, changes to flow, changes to surface water and groundwater flow patterns. We've also got to understand what our background water quality is in the area, both for surface water and for groundwater. We've got to understand how the current conditions are influencing our system. So some of the things that are important is the arid climate and topography. So runoff, snowmelt collects in, say, a closed basin that Hamish was referring to earlier. You get evaporation, you get discharge. Over time, you might see concentration of the salts in those runoff waters, leading to brackish or saline ponds in the area. Some of the other things that we need to consider is that it's a managed surface water system. There's lots of water licenses on the creeks in the area, so we need to understand how withdrawals and timing of those events might affect both quantity and quality. And there's historic mining features in the area. There's pits in the area, there's water in the pits, there's waste rock and seepage collection facilities that are already built in that area from previous mining efforts. So they've had an effect on water quality, and we need to understand that before we even get going looking at what might happen as part of our study. And ranching as well, how the surface of the land is used has an effect on runoff and infiltrating water quality. So the effects assessment on quality and quantity is carried out with the mass balance water quality model, which is tied to the water balance model. So we look at how changes in surface water quantity and groundwater quantity and source terms for both background water qualities and source terms for waste rock, ore stockpiles, tailings, runoff from the open pit walls during mining, and into closure might develop how those flow streams might mix and what the resulting water qualities are. So the outputs from that model are looked at initially by us. We screen them against some of the guidelines that are available to us, and that'll be on the next slide. But we also provide them to the human health and ecological risk assessor. He'll look at, or she'll look at, water quality on effects on human health. We'll provide them to aquatic biologists and fisheries people that will look at what the potential changes in chemistry or quantity might mean to the valued components of that system. And depending on what we hear back, we might need to go back through it again and look at another iteration to try and optimize conditions and minimize effects a little bit. In terms of guidelines that are out there for assessing water quality, there's the Canadian Council of Ministers for the Environment, Canadian Environmental Quality Guidelines that apply to, or can be applied to, aquatic life and agricultural water uses for looking at screening level effects on livestock and irrigation. There's Health Canada guidelines for drinking water quality, and there's BC Water Quality Guidelines for drinking water supply, for raw water, for aquatics, for wildlife, for livestock, for irrigation, and even for recreation and aesthetics, the water that you're swimming in down at Kamloops Lake if you go there. I don't know. So that's the extent of our presentation. So we'll open the floor for questions.
Well, thank you. So we'll move to our question period now, and then this will be followed by a short break afterwards. So question number one.
Thank you very much, gentlemen. I've spent 40 years, a little more than 40 in British Columbia, but I've spent 40 years mostly working on water issues. in the province of BC with Canada and also with Canada, US, and Mexico on the environmental side agreement to NAFTA. And so I have some real concerns here, and all of them relate to water. First of all, with the billions of gallons due to be taken out of Kamloops Lake and out of the Thompson River, I have major concerns. I don't know whether you're aware, and I want to make you aware of a couple of things that I'd like you to consider. And that is, we've had a pulp mill for 40 years, and Kamloops Lake is layered with layers and layers of toxins from this pulp mill. And so I'd like you to consider the fact that by lowering and also by disturbing these layers, there are 5 First Nations communities downstream who drink the water, and there are 2 towns, both Savinaw and Ashcroft. This is their main drinking water, and 5 First Nations. So consider that. But the thing I guess I've worked on more is other species other than people. And salmon are in a major concern to us here. Our coho are endangered. And lowering the level of both the Thompson and also Kamloops Lake will make the water warmer, the flow will be lower, and the water level will be lower. And that's a real concern because it's already a concern. We already have the problems. And then on top of that, we've got Gurin Creek, Peterson Creek, and Cherry Creek with toxins that are now going to be traveling down into that as well, and I believe that'll also affect the salmon and many, many other species. Then the second problem that I have concerns about, to begin with, we had read that Peterson Creek was going to be, oh, I can't remember what the words they used. I now find out that in fact Peterson Creek is going to become a big pipe for 5 kilometers up there. And we have beavers, just many, many species that use those wetlands. And so I'd like you to look at them and just, you know, listen to the concerns, you know, of the residents as you're going to hear in the next 4 days, because I believe that the studies that you're doing are going to, you know, you can make a change and make that impact not so great. Thank you. And I'm sorry, I don't really have a question except will you please consider the things that I've suggested.
Thank you for your comments.
Thank you. Next question.
So I just want to say congratulations. I think we've come a little bit forward in the fact that the last open house I went to with Ajax, Jim Whitaker stood up and said there's no aquifers underneath where the pit is going to be, nor will any of them be affected. So congratulations in actually identifying the fact that we actually do have aquifers. My question is actually in terms of the groundwater modeling. We have a lot of underground streams in Aberdeen. We've already had problems with some of the houses in Aberdeen because of that, significant problems. So my question is, how are you going to model and have a baseline before you start construction on this mine to know what our underground stream problems are, or not what they are, but what the baseline is in terms of the significance of that? Like, how do you do that and how do you get a handle on that?
Sure. Well, for starters, we look at the water levels in registered wells in the area. So we've got a fair amount of data available all over the regional study area. There's also a data sharing agreement that will be implemented with the City of Kamloops to provide access to the information in that area. So there's data out there to be reviewed, and that'll be considered as part of the study.
And just to follow up on that comment, thank you for the presentation on the groundwater and water quality issues. There are known stability issues in Aberdeen, and there's a tremendous amount of information the city has generated, including models, to ascertain stability of those old slide areas. I didn't see any of that information on the graphs that you showed. I assume that you're going to be utilizing the information that City of Kamloops has collected?
Yes.
And are you also going to be utilizing the models that they have? Because the factors of stability are well less than 2 at present.
That's more of a geotechnical concern. What we'll be looking at specifically is the effects of the project on groundwater in the study area. So data that might be available to us from the city in that area would certainly be considered. As to whether or not we might use modeling results from those areas, it would depend on what the purpose and specific study aspects of those models were developed for.
The purpose of those studies was to determine the stability of the historic slide areas in Aberdeen prior to development proceeding. And it's your groundwater quantity issues are directly related to the pressure, the groundwater pressure in those areas. And if those pressures do increase, there will have to be measures undertaken to assure stability. So I'm certain that you're going to have to, have some liaison with the geotechnical engineers to assure stability as the mine, or if the mine is developed.
Certainly as a matter of the study, changes in groundwater levels that may be due to the project in Aberdeen would be communicated as part of the study findings. So they would be available to the city to look at them. So that's in response to how
As I understand it, you're going to be developing some information relative to the groundwater quantity that may or may not increase. And then it will be up to the city to utilize that information, determine what impact it may have on the historic slide areas in Aberdeen?
I can't speak to specifically what the city might choose to do with it, but in terms of what the scope of the assessment in Aberdeen might be, it's in terms of the groundwater flow, it's looking at the changes of groundwater levels and what changes in flow patterns, water levels, and quantity might occur as a result of the project. So how that might be translated into a stability assessment is something that could be considered. It's maybe not the appropriate aspect of the environmental assessment to look at that with.
I think for the long-term security of the city of Kamloops residents, it would be imperative that the groundwater assessment study look at the historic slide areas in Aberdeen and the modeling that has previously been done, all the piezometric data that's there, and integrate that as well as your new information into those models. Thanks.
Great, thanks. I think that question has been noted. Next question.
I've attended several information sessions so far, and one thing I've noticed is that some folks will come up with a concept or an idea that says, so worried about the effect on the Kamloops Lake or the rivers, and that this mine will actually dry up the rivers and the levels in the lakes will go down significantly. I mean, is this something that's even feasible?
In terms of impacts to Kamloops Lake, Kamloops Lake is an extremely large water body relative to what the mine is proposing to abstract from the lake. We haven't done there's not a final number yet in terms of how much water the mine will or will not use. So I can't give a specific answer to that, but I can say it is a couple of orders of magnitude difference between what the mine needs for water versus what flows in Thompson River.
As you know very well, models are only as good as the inputs, the approximations made, the parameterizations, and what science is in and what science is out of them. And mountain ecosystems are quite different than lowland ecosystems, in large part because of the water inputs being different. And one of the major sources of water in upland ecosystems is the collection of fog by vegetation. And there's 1,000 peer-reviewed publications looking at that. And that impacts not only the amount of water going in, but the water chemistry. And probably in the mine area, about 20%, I would guess, of the total water input is fog deposition. And if you take out the trees, the shrubs, the grasses from 40 square kilometers, you're removing a water input, which is fog collection by vegetation. So my question is that part of your model?
The model doesn't specifically look at the source of water per se from fog, but I can say that if we take, for instance, the Peterson Creek watershed, the upper watershed gets up to about 1,500 meters elevation. The mine itself, the proposed mine itself, is around 900 meters. We definitely see a strong orographic effect, so what we see is much more runoff at higher elevations, contributing to the lower elevations. And so we see a decrease as we go from higher elevations to lower elevations. The mine itself has a very small footprint when we look at the overall watershed. So,
but for some of the watersheds in your graphs, the mine has a big footprint, and this is a specific water input that really needs to be quantified, not just dismissed by waving your hands or something. It needs to actually be looked at, because the mine going in could actually reduce significantly the water input to that footprint.
I mean, absolutely, any mine has an impact on the water going into the environment, and that's taken into account in the models.
Thank you. Last question before the break.
You use the expression geochemical source terms. What exactly does that mean?
Certainly. Water quality source terms, geochemical source terms. What you do to evaluate the quality of the water that is running off or infiltrating through, for example, a waste rock pile, is you would consider how that water quality from rainfall incident on that waste rock pile might evolve as it runs through that waste rock or across that waste rock and reaches a point where it could run off into a seepage collection pond or a stream or infiltrate down into the groundwater system. So the evolution of that water from rainfall down to its runoff from rock would be a geochemical source term for a waste rock.
Okay. Have you then considered what the effect of residual sulfides would be in the water quality, oxidation of any residual sulfides?
That's getting a little bit further out of my area of expertise, but there is a geochemist on the project to look at the evolution of the water chemistry as it runs off.
Okay, I hope he looks at it. Thank you.
Thank you for your questions. Again, if there are questions that you haven't had the opportunity to ask of the panelists, there will be an open session after the last session. As we would like to keep to our time limit, ending at 9 o'clock, we will now take a 10-15 minute break, and I will call you back for the fourth presentation in about 10-15 minutes. So help yourself to what's on the back tables.